So we're going to continue with our RIP configuration. We've configured Atlanta and Sacramento. Now let's go over to Charlotte and do the same thing on this guy. So we'll do config T. You can see I cheated there a little bit. I couldn't remember if I'd configured RIP on this guy in preparation for this lab. So I hadn't because there's no RIP database there. So we'll do router RIP. We'll do version 2. We'll go ahead and turn off auto summarization. And then we will do network 10.10.10.0. We'll do network 10.10.20.0. And we'll do network 192.168.2.0. Go ahead and write this config over in Charlotte. And then we will do a show IP RIP database. And after just a moment, we should see some of these other networks come in. But while we're waiting for them, let's go ahead and remove these static routes. So we'll do show, run, and then do include IP route. And we'll just take these out by putting no in front of these. So we'll copy this to the clipboard, this first line here. We'll do no, right click and paste that guy in there. Do the same thing for the second line. And do no. And the reason why we have to do that is because static routes always win. No matter if you learn a route through a routing protocol, if you have a static route for that same route pointing a different direction, then the static route will always win. So now let's do show IP route on this guy. And you'll see we're learning routes through RIP. There's our 192.168.1.0 network. We still haven't learned about our 10.10.1 network, but let's go ahead and remove these static routes on Atlanta and Sacramento, and we should have RIP routes distributed throughout our entire network after just a few seconds. We'll do show run, include IP route, and we'll do the same thing here, and I'll pause just because I'm sure you don't want to watch me do that. So now I've gone to the Sacramento and Atlanta routers and removed its static routes, and now if we go to Charlotte, we see our 10.10.1, 10.20, we see our 192.168.1 and 2. The real test is if we go over to Sacramento, do a show IP route there, we now have routes to all of our networks learned via RIP. So I know you might be thinking, well, big deal, we just traded static routes for RIP routing. Well, let's show you the power of RIP routing. Let's go to Atlanta and let's configure a 10.10.30 network on a loopback interface here and advertise that to RIP, and we'll see that this network shows up on our Charlotte and Sacramento routers without us having to do anything else. So we'll do interface loopback 10 on this guy. We'll do IP address 10.10.30.1. 255.255.255.0, and then we'll go into router RIP, and we'll do network 10.10.30.0. Go ahead and write the config. And RIP, as we mentioned, advertises the network out every 30 seconds. So let's see if it's over here in Charlotte yet. So we do show IP route. And yes, we actually already have a 10.10.30 network advertised over here in Charlotte, and it knows it's behind this 192.168.2.1 router. Same thing over here in Sacramento. I'll bet you that route has already been advertised over to Sacramento. And there you go. 10.10.30.0 is behind 192.168.1.2. So you can see having a routing protocol on board can really make your network administration a lot easier. You add a route, you put it in your routing protocol, and all the other routers on the network learn about it. And of course, that does introduce another moving part and another potential point of failure into your network. But if you keep on top of your routing protocol and you only advertise into it the networks that you really want to advertise into it, then everything should be good. So now we've configured RIP on our small lab network, and this concludes our discussion of configuring RIP.